Good morning, everyone. I am Joe Kovacic, work in the DISA Emerging Technology Directorate. We would like to welcome you to today's technical exchange meeting. XQ Message will be presenting a Zero Trust Data Platform. Let us commence with the presentation. So over to XQ Message.
Wonderful. Thank you, Joe. I appreciate the opportunity to present today. This is a follow-up meeting from May 17th, where XQ Message presented to the DoD CIO Defense Industrial Showcase for Dr. Batra. We are a company, a small startup out of Silicon Valley that built a Zero Trust Data Platform over 3 years ago. And we were very excited to see the DoD published their revised Zero Trust Data Strategy in November of 2022. What was relevant to us in that strategy is for the first time, the Department of Defense defined Zero Trust Data. And we'll have Junaid Islam, who's the architect of the platform, talk a little bit more about how that came to be. But I wanted to say a couple of things about the importance of Zero Trust data as it complements other types of Zero Trust data security architectures. And certainly want to applaud DISA for the work that they've been doing with Thunderdome. So we're here today because of the compromise of the electromagnetic microelectronic supply chain by near-peer competitors and an increase in cybersecurity threats from near-peer competitors. And in order to clean the supply chain, it's going to take decades in billions. But we can't wait for a decade to go by. We have to find short-term mitigation tactics to ensure that we can be agile and move data in a cooperative fashion with coalition forces and amongst ourselves to protect our nation's sovereignty.
About the word Zero Trust and where it came from. With all of the marketing on Zero Trust, you'd be thinking some cool startup invented it. The important thing is actually Zero Trust was invented by the DoD. And I think that's important to recognize the people who did the work. So the word Zero Trust actually is pretty old. It comes from the Cold War. And the idea is you have Zero Trust in someone who's a Russian spy. And because you have Zero Trust in them, you set up a whole set of countermeasures around them. You follow them, you stake out their home, you interview people they have met, right? So that's where the word comes from. It's quite an old term. The first Zero Trust network actually was built during at the White House during President Reagan's time. So it's a very specific topology for Zero Trust. And what they did, and this is the network operations team of the White House who worked with WACA, they basically took an encrypted network and built an encrypted network on top of that, and then used relays to come in to that network. Now, today we think of that as a Zero Trust network, but the history of it is quite old. The first version at the White House was originally for a phone, so from the Situation Room in the basement out to the airplane. And then the second version, they did a fax version, and then the third version was really X25 that would allow them to basically circumvent the world. The first use of a Zero Trust network, I saw at the White House, really starts with counter-terror and counter-narcotics operations. In 1987, the United States had launched a set of missions really to protect civilians in Colombia and Peru. And because the Colombians had actually put people into the phone company, they had to figure out a way to tunnel through those phone networks without being detected. So because they already had this network at the White House, this is the design they use. Same concept of overlay encryption with gateways to be able to come in and out. The second deployment of the Zero Trust network was actually in Operation Desert Shield, which was the preamble to the war for counter-terror operations. So, and there the challenge was being able to operate in Saudi Arabia and without any detection. So with that, we're going to talk about Zero Trust data. So in the DoD document in November, which you may have seen, you saw zero trust data. So the question you might ask is, hey, is this special? Why did DoD talk about zero trust data? Data has been around for a long time. Well, it's revolutionary. Zero trust data does three things that have never been done before in the same protocol. And we're going to show you all of this, and you guys are going to be experts. The first thing is it integrates VPN and file encryption into one protocol. The second thing, it brings or introduces decentralized key management, which is critical for JADC2. And the third thing is it integrates the tracking and compliance of data. So audit and compliance is actually built in. If you look at the DoD document from November, you'll see zero trust data defined, and you'll see 7 features. And some of them seem kind of boring, like compliance and risk management. You think, hey, this is not new. What's the new revolutionary part? Well, the new revolutionary part is the goal is this is all being done in the same protocol. So zero trust data is supposed to be more elegant and efficient than all the systems it replaces. Lower cost, cleaner, more effective, better countermeasures to cyber attacks from foreign governments. So what's the thing that really makes it happen? The thing that makes it happen is 4.3, which is labeling. It's kind of hidden in there, but I'll show you why the labeling is kind of magic. So I'll give you a short course on labeling. So think about any data object moving from one network to another or a device. How do you track it? Because you don't know where it's gone. So one way to do it is to create a label, put that label on a policy server or a mobile IP server, and when the device moves, it updates the database label so the person can connect to the policy server and you know where the object is. If you look at this, and if you've been around long enough, you'd say, hey, this looks like mobile IPv6. And the answer is you're right. So the design of zero trust data really happens over 20 years. So if you think about the word zero trust, now 40 years in the making, starting at the White House and then going to counterterror, zero trust data is about 20 years. So at Net-Centric Warfare, where I worked as a contractor, we used mobile IPv6, which is a concept of labeling blocks of data and also devices to create mobile VPNs. When that project got finished, that labeling concept went over to the intelligence community, where they use labeling to basically encrypt, say, satellite images that an analyst would get. So you get the image, and then you see the label, and then you attach to the label tells you what a policy server to connect to. And then if you're cleared to get that satellite image, you get the key. Then this concept moves back to DoD, and you can see where we end up with zero trust data. You have the labeling for VPNs, then you have the labeling for data, and someone says, oh, why don't we use the labeling for VPNs and file control both in one? And that's where we got here. And this is why zero trust data is so elegant. But I want to stress, though, when we talk about zero trust data, think of all the people who've worked hard to create it. So here's the zero trust data workflow. And again, I want to stress that XQ message, we did not invent zero trust data. What we have done is the implementation, and I'll show you that in a minute. So the way zero trust works is you have an object, which can be a phone call, a satellite image, it can be telemetry from a drone, it can be any arbitrary object, it can be a sensor, right? So that object is first encrypted using a random number to create a unique key, and then a unique identifier or label is created. And that's very important. There is no database entry that says what it is. The entry itself is a random number by design, right? Because you don't want the key encryption system to leak information. So that label, which is a random number, and the key, which is a random number, and the policy to access it goes to a policy server. Then the object moves from one network to the other, and the label tells the receiver what policy server to connect to. So then the receiver connects to the policy server, and the policy server can do things like identify location, identity, check your token, whatever. Once it does that, it gives the key, so the receiver can now unlock the data. And then finally, all of this is logged. Now, if you look at this and you think, boy, this is pretty complicated. Well, I want to stress that not only is it more elegant and simpler, it's better than anything else out there. And I will show you a quick demo. So let me go to secure chat.
So Junaid, while you set that up, I kind of want to highlight a couple of things. When you talk about the label, that meta tag is completely random and unassociated with any information on the data, which makes that unique. You also mentioned the key, and the platform is crypto agile, so it can be any type of encryption. Obviously, the enhanced quantum encryption would be the best type of encryption to use with the platform, but we can use any type of encryption. This is not an encryption platform. It is a zero trust platform that is crypto agile. Did you want to make some comments on those 2 points, and then maybe stop and see if there's some questions?
Sure. So while I'm doing that, I've started a demo on secure.chat. So secure chat is the most secure chat in the world, and we have if you saw me sign in, you can play with this after the presentation. It's online and it allows people to learn. So Randy, when you have a second, you want to put your mobile phone to the QR code. This is a live demo. This is not fake or canned. This is not a video recording. So Randy, you want to tell me when you're in?
Yep.
All right. So as you might have seen on the video, Randy pointed his phone and he was able to get in. So this is chat, and like I said, it's a way to learn about zero trust data. Now remember, we talked about the random identifiers. So in the secure.chat demo, again, it's free, it's online, you can play with it. It's a way to learn about zero trust data. Once you sign in, you see this green icon, it's like this key icon. So when you click on it, it actually shows you the database entries. And the database entries, this is for the policy server, are random numbers. So if you look at this, there's nothing in that random number that tells you this is a chat. So now imagine this running in a DISA network where DISA might have millions of conversations and you're managing keys. You don't want to leak information about the mission. So using random numbers as your database entries hides that. So the other thing I kind of mentioned is integrated logging. So when you click on the label, it automatically generates in real time a detailed history of that key. And you can see I'm in California and Randy's up there in the Washington area. So what's really interesting is this is all in the same protocol. So think about from a DISA perspective where you have so many users and you want to manage the keys, you have managed security, but you also want to do logging and compliance. This is all built in. So I want to stress that zero trust data is much more elegant. And then one of the cool things we can do is, I mentioned decentralized key control. So when Randy signed in, he generated the key on his phone and I generated my key on the laptop. But this means I also have the ability to manage the keys. So if you put your finger on the message, you can see the delete message. So in this case, I deleted the message, not just on my side, I deleted it on Randy's side, and I destroyed the key. So this is very good in terms of being able to clean up the network. So again, secure.chat, I'll just go back to the screen. It's online, so feel free to play with it and learn about zero trust data. The other thing we have at XQ is, so this is to learn zero trust data. The other thing we have is we have applications such as email where the zero trust data is fully integrated in. So let me just go to, sorry.
So Junaid, in secure chat, this is all software, and the entire software stack is loaded into the browser.
That's correct. That's right. So it's a full decentralized. So Randy, are you able to see my Gmail screen?
Yes.
Yeah. So the reason I showed you secure chat is so you can see the inside of the zero trust data protocol. When we actually do an application like email, it's completely hidden. So this is inside of Gmail. It's fully integrated. And then the user doesn't see anything. They're just able to hit the button and they can just send. And let me just come here. And then you can see this message. And then you can see it automatically decrypts. The other thing we have is full integration into Microsoft. So, sorry, it's just a little cumbersome switching from screen to screen. So
another point of clarification, the sender is the one that's initiating the encryption and the secure messaging. The receiver does not need to have an application or an applet on their end, correct?
That's correct. So there's two modes. Both users have this integrated, or only the sender has it. If you want to do CMMC level 2 compliance, which is one of the applications for zero trust data, you really want both people to have it. So this is there's a lot of DoD contractors. In fact, DoD uses Microsoft email. So what you're able to do is just get this encrypted. You saw it got encrypted ahead of you, sorry, in front of you, and then when you click on this, it basically unlocks. So the important thing here is the reason we showed you the secure chat demo is so you could see the protocol, but now this entire protocol is inside of Gmail and Microsoft. So very elegant implementation. And of course, the nice thing here is you get all the features of zero trust data. And I'll go back to the presentation here. All right.
If you have questions, please speak up. Willing to answer them during the presentation, or you can drop them into chat.
Great. So now that you have a sense of the protocol, so as I mentioned, there's a lot of applications for zero trust data at the Department of Defense. One of them is CMMC level 2 compliance. As many of you know, CMMC level 2 is being required for all DoD contractors. The challenge is not the bigger contractors who have on-site staff. The challenge is the smaller contractors, the 10-person veteran-owned companies. And what we can do is by encrypting their email and providing access control, we can ensure that only authorized and authenticated people can view it. And if you remember, we have that mapping function. You saw that in the quick demo with Randy. One of the great things is that there's a requirement that DoD emails don't leave the United States or the users aren't outside the United States. It allows the users and the people verifying that they are compliant, that everything is working well. So that's one advantage or one application of zero trust data. So we, as I showed you, are fully integrated into Microsoft Office. So it's fully transparent. So you get all of the features where the data is encrypted on their laptop before it goes into Office. Then after it goes, we're using Office just for storage. There's no CUI processing in the cloud, which is very nice. That was a concern of people in the past. Oops, sorry. Another application of zero trust data is now JADC2, or they just, I believe, changed their name to CJADC2, which is Combined Joint All-Domain Command and Control. So JADC2, and you guys are experts, really involves a lot of data sharing at a massive level between sensors and warfighters. So imagine if you had to centralize all that encryption management, it would be exponentially difficult. By distributing by using zero trust data becomes a very elegant approach, because first, all the encryption is being done at the edge on the drones, on the warfighters, comm units, but it's also the policy servers that are connecting them can also be deployed at the front line, so that if they lose connectivity back to the new US, they can still keep sharing data. The other nice thing is if you think about coalition operations. Sorry, was there a question? Or I don't know if there was some background noise. No? If you think about the CJADC2 model, you can see how zero trust data is a very elegant way to create a lot of encrypted partitions where you still have interoperability, but the operation is completely decentralized. So if you're going to have that much data, petabytes moving through DISA, being able to create basically virtualized encrypted domains with their own policy managers is the elegant approach. And then the nice thing is, of course, you can also gateway data, but you gateway data by gatewaying the encryption policy and the key from place to place. You don't have to put everybody on the same network. So this is a very elegant way to handle massive amounts of encrypted data. And to Randy's point, the zero trust data architecture can support all kinds of encryption. It's not locked on to any one encryption. We can run AES, we can run XOR if you're just doing video streaming, or we can also run the new NIST post-quantum algorithm. So we've already prototyped and run the first of the 4 algorithms successfully in our platform. So that's really nice. You can actually be running different algorithms with different keys all at the same time, and you can have one policy server or multiple, or you could have hundreds of policy servers. So it's scalable in multiple dimensions. Another example or a great use case for zero trust data is in the development of AI. As you know, the Department of Defense has a huge initiative across all services to basically start building new AI models. This is a really difficult problem from a developer perspective because you have data which is sensitive, and then you have multiple users or developers, contractors coming and going. Sorry. So what you can do with zero trust data is create a zero trust enclave. So the idea is, if you remember about how we can set policies, say email to email, we can also set policies where on that same piece of data, we can have different defense contractors come in, work on that data on their machine learning model, and then leave or have their access shut off, and then somebody else be granted access or be granted access to multiple parties where you know who they are, and you can also geolocate them. The ability to do this is kind of revolutionary. So from an AI developer perspective, is creating a zero trust enclave using zero trust data is a great way to manage access to contractors working on complex machine learning models. Oops, sorry. So as I mentioned, all the demos we showed today are actually online. Secure.chat is there, which is a great way to learn the zero trust data protocol. But we are in the Gmail store, and we're also in the Microsoft store. So we have free versions. We're a browser extension for Chrome. So you can use this at home, but we're also in the Microsoft Marketplace where you can find us, and you can just add the Microsoft agent to your account. You probably won't be able to do it in a DoD machine, but you can do it on your home one. And you can actually, you also get the dashboard, so you can actually play around with it and learn how zero trust data works. And then again, this is all free. You can play with it. You don't have to pay us a penny or anything like that. So, we would love to open it up for questions after this. So the couple of highlights I want you to take away from this is zero trust data really is new. It's a lot of people have worked on this at DoD actually for 2 decades now, and a lot of people have worked on zero trust at DoD now for 40 years. Zero trust data specifically integrates countermeasures. Specifically, as Randy said in his opening comments, if we're looking at foreign governments or adversaries stealing our data, zero trust data is designed to fight data exfiltration. And how does it do that? By basically encrypting everything and keeping the key separate from the data. So if someone does steal the data, they won't be able to get the key because the key is kept by a policy server which verifies identity and location. and can also do things like kill data. The second thing about zero trust data, it really simplifies compliance. If we're thinking about small DoD contractors who have to now struggle with CUI enforcement, zero trust data really makes it easy. It ensures that only authorized people on a task order from DoD can see DoD documents. It also immediately logs everything, and it creates a really nice map of where they are, whatever state, and it actually shows all the messages going back and forth. And then also, as we've mentioned, zero trust data is a foundation for a JADC2 or CJADC2. Its ability to scale, handle lots of it's scaled to millions of endpoints without sweating. The ability to run different algorithms, the ability to have hundreds or thousands of policy servers in parallel, the ability to create an encrypted network for coalition operations, which might be only 2 days long, and then after you're done, basically wipe everything out, really is kind of revolutionary. So with that,